Alright, let's multiply and divide some rational expressions. I'm going to start up here with number 5. The first ones are just a chance to remember the process that you're going through using some simple numbers so that you can then apply it to these bigger problems. We'll start up here. It's important to remember that with multiplying, I can do things like this. I can say 9 divided by 9 is 1, so both of those become 1. Because I could easily write this, since with when we multiply fractions, we just multiply straight across the top and the bottom. So I could actually rearrange the top and the bottom and still get the same answer. So you see here, 9 divided by 9, that's 1, so we can divide those out. Similarly, 2 divided by 2 is 1, and 8 divided by 2 is 4. They have a common factor as well. And then x to the third over x, that's the division rule, if you remember when we talked about powers. So that would be the exponent of the numerator minus the exponent of the denominator. So x squared is what that becomes. So you have x squared over 4 times 1 over 1. So that's just x squared over 4. Let's move down now to number 7. And right away, there's 6's all over the place. So let's divide this one out. That becomes 1. So we have 1 over b here. And then let's factor a 6 out of the numerator on the left fraction here. And is there anything else we can factor out? Factor out a 6. Do they both share something else? They both share a b. So we take out a b, and what we're left with is a b, because 6b times b is 6b squared, minus 6 times 8 is 48b, or 6b times 8 is 48b. And then that's over 6 times 1 over b. Alright, well, here we have the same situation again. 6 divided by 6, that's just 1. We also have a b divided by a b over here. So that becomes 1 and that becomes 1. So we have 1 times b minus 8 times 1, which is just b minus a, right? And that is being divided by 1 times 1. So really we just have all of this is equal to b minus 8. So that's number 7. Jumping over here to number 8. Move that. Over here to number 8, we got a little more complicated situation, looks like. Okay, so look at the first fraction, a minus 1. Is there anything we can factor out of that? No, it's already linear, there's no greatest common factor. Same thing with a plus 7. We just bring those down. Then we have a quadratic over here. So the n term is 49, leading coefficient 1. So all I have to say is any factors of 49 that add up to 14. Why, yes, 7 and 7 add up to 14 and multiply to get 49. So we have a plus 7. This should not be an equal sign. This should be a multiplication sign. And a times 7. So the numerator's factored. Now let's factor the denominator. Here we have greatest common factors we can take out, so let's do that first. They both share a 5, they're both divisible by 5, and then they both share an a, so we can factor out an a. And what's left in the parentheses here to be the 5a is multiplied by a to get 5a squared, and 5a times a positive 7 gets you the 37, or the 35a. Alright, now we start to look to see if there's anything we can divide out. Well, right away I see a over 7, a plus 7 over a plus 7. That's just 1. And I have another a plus 7 divided by a plus 7. And I know when you get to this point, you're going to think, well, I have an a over an a. But you cannot separate the a minus 1, or the minus 1, from that term. So you actually cannot divide that out. It's a minus 1 over 5a. And that's as simple as you can get it. just remember, when we have these subtraction and addition signs, they kind of change the game as far as what we can cancel out. When we have multiplication, we can divide pretty much everything out as long as we have a whole term in the numerator and a whole term in the denominator that are exactly the same. We can divide those out to equal 1, which is why we take something like this quadratic up here and we factor it. When we factor it, we get two linear terms, and we can see if we have a linear term in the denominator that matches one of those. Let's jump to the next page, see if we can get through this one. So number 9 here, we started division on this problem. The rest are multiplication, but we start division on this one. First term stays the same. There's no greatest common factors here. There's nothing that we can simplify using a greatest common factor. And now, to do division of fractions, we actually flip this fraction, do the reciprocal, flip it over, and multiply. So we're actually going to factor this and put it in the numerator. So I have factors of 70 that add up to negative 17. So this is positive, and I'm trying to get to a negative middle number, negative b term. So my factors both are going to have to be negative, and that way they'll multiply to equal to positive 70, and that would be negative 10 and negative 7. So n minus 10 and minus 7. That's all divided by 1 because that was the numerator of that fraction. So now we've got it factored. We have flipped it over. We've made the denominator the numerator, numerator the denominator. And so now we can multiply straight across the top as soon as we simplify. So in the numerator here I have an n minus 7. In the denominator here I have an n minus 7. So those two things can be factored out, and I have 2 times n minus 10 over 1. That's just 2 times n minus 10, or if you wanted to, you could write it 2n minus 20. All right, number 10. Look at the numerator. What's the greatest common factor? I'll let you think about it for a second. 15. So we can take out a 15, and we're left with p minus 2. Sorry, it started freezing on me. I had to restart things. All right, now let's factor the denominator. Greatest common factor of 30 here, and they both share a p. So we can take both of those out, factor both of those out, and we're left with p minus 2 in the parentheses. So, woohoo, I already see a p minus 2 and a p minus 2. Let's see what else we get here. All right, p minus 3, can't simplify anything there, but the denominator has a 5 that we can take out as a common factor. We're left with p plus 8. Now, it doesn't really matter how you divide these things, but if you look at the very beginning, we have a 15 and a 30. Those are both divisible, right, by 15. So 15 divided by 15 is 1, and 30 divided by 15 is 2. And so we're left with only the p minus 3 in the numerator, and then we have a 2p over here times 5p plus 8. And we can combine the 5 and the 10, and we'll just leave it factored. You can multiply that whole thing out if you want. It'll be 10p times p plus 8, or 10p squared plus 80p if you multiplied that out. And there's your answer for number 10. See if we can knock out these last two for this first video. No, I'm just kidding. We'll make a different one.